Hello everybody, this is Patrick Bray, and welcome to my character movement project. For this project, I decided to use Mario, because I love Mario. I used him, specifically Mario Kart, for my last project, but for this one, I'm going to be using the 2D side-scroller Super Mario Bros. Wonder to demonstrate the concepts today. Because almost everything Mario does in that game is a linear transformation, so here are 8 of them. To start off, we have a very simple one, just a horizontal translation. And in-game, this would literally just be Mario moving to the right. But for the sake of the math, we're going to take a look at this little graph that I made right here, and we are just going to add 5 to the x-coordinate using the translation matrix. The y values don't move, so 2, 3 becomes 7, 3. Next up, we have another very simple transformation, just a vertical translation. Instead of walking, we are jumping. That's what Mario does, and he does it very well. If we look over to the grid, it's the same matrix, just vertical this time. That 4 in the Y row is what shifts Mario 4 units up, representing the jump. There's no way to determine how many units he's traveling in the game, so I'm just picking random numbers here, so bear with me. Next up, we got another simple one. This is just a scale by a factor of 2. Mario grabs a super mushroom and he gets bigger. It's a 2x2 scaling matrix which doubles every coordinate, both the x and the y, so the whole sprite expands outward, and Mario doubles in size. Our next transformation is a reflection over the y-axis. In the game, this would just be Mario turning around. Ignore him running here, because the transformation I'm talking about is just him turning around. You put the -1 in the x position of the matrix, and that negates every x coordinate, flipping the sprite horizontally so that he faces the other direction. Now we're going to blast off a little bit, go into space where we'll have 0 gravity so that I can showcase a reflection over the x-axis. Same idea as before of just changing the direction of the sprite, but this time it's vertical. And Mario is now upside down completely. You put a -1 on the y-axis, and that maps Mario below the x-axis, upside down, just like he is floating in space. Alright, we're going to use some star power for this next one, because when Mario uses the star, when he jumps, he flips around. And we're going to try to get this so it pauses. There we go, perfect. 90 degrees. In a rotation matrix, when it's 90 degrees, the cosine becomes 0 and the sine becomes 1. So the matrix simplifies down to just top row 0, -1, bottom row +1, 0. That means in practice, any point at xy gets mapped to -yx. So Mario, standing at 4, 0, gets sent to 0, 4, straight up the y-axis. He's rotated a quarter turn counterclockwise around the origin. The application of this next one is very simple. It's just a shear. So Mario's sprite is rotated forward when he starts running. The shear factor shifts x proportional to y, so leaning the sprite in the direction of the motion without changing y at all. And in this example, Mario has a shear factor of 0.5. And this last one is special because it's a composition, meaning it's multiple transformations in succession. We're doing a shear and a scale, so Mario is mid-run and he hits a Goomba, he loses his mushroom. First, the shear matrix leans him when he runs, and then the scale matrix shrinks him by half when he loses the mushroom. Multiplied together, they become one single matrix. And that is the composition. And there you have it. That is all of the transformations. Here is my Python code, including everything, including the print statements as well. Every button press in a Mario game has some version of this, just running thousands of times, every single time you play this game. It's incredible. Forgive me for the shoddy animation work on some of the grids. I am not an animator, I am an actor. I worked really hard to try to get it to look good. I think I did an okay job. I hope you enjoyed watching. Have a great rest of your day.